Alright, so this is going to be my walkthrough video for finding the distance between 2 points. So I'm just going to get right into it. We've got 2 points. How I would write it, the formula for distance in words, it would be the vertical component squared plus the horizontal component squared, and then take the square root of it. If I wanted to write it mathematically, then it would always be subtracting my x's squared and then taking the difference of my y's squared, same thing, and these are the same formula. So there's number 1. Number 2, create a triangle by showing the vertical and horizontal distances between 2 points. So this I drew in a previous video, but every triangle is going to have this sideways part, horizontal, and then it's also going to have this up and down part, which is vertical. And that's it. So there is 1 and 2. Okay, so for 3, you're going to be simplifying roots, which is something I did its own video for to review. But if you already know how to do it, we're just going to go through them pretty quickly. So I'm going to take square root of 90, 60, and square root of 128. So square root of 90, we could do 9 and 10, you could do 2 and 45. All right, we're gonna do 2 and 45. When I was bad at these, what I would always do is just take out 2's if it was even, no matter what. 3 and 15, 3 and 5, and you know what, that will get there eventually. So I got a pair of 3's, I got a 2 and a 5 left over. So I'm gonna get my pairs in front and the outside, leftovers on the inside. 2 times 5, so I got a 3 root 10. All right, let's do this root 60. So when I take square root of 60, I'm just going to keep brute forcing these 2's. I'm going to do another 2. Oh, I got a 15 again. I already did 15 over here, so I know it's 3 and a 5. I got 2 2's, a 3 and a 5. There's my pair of 2's. I'm going to take that 2's out, but I got a 3 and 5 still left inside. And I'm multiplying them together, and I randomly wrote a 3 for some reason. 2 square root 15. Boom. And then I've got this last one over here, root 128. So I'm going to keep brute forcing the 2's. Looks like 64, 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. So look, this is a lot of 2's, right? Well, 1 pair, 2 pairs, 3 pairs, and an extra 2. That's 1 2 on the out, 3 2's on the outside, 1 2 left on the inside. 2 times 2 times 2 is 8. 8 root 2 is my answer. So look, if you had seen the 64 here, you could have stopped here and been like 8 8. Hey, look, that's a pair, and I'm gonna take it out. Just so you know, that is an option. All right, that's number 3. All right, so for number 4, we're going to explain the error in what this person did, finding the distance between these 2 points, A and B. So it looks like I'm just going to write out their work a little bit, and we'll go step by step and see if they did anything wrong. So let's start with this first step. Did they set everything up correctly? So we got a 9 minus 3, negative 3. And then we got a 3 minus a 4. So this is, right now they already have x1 minus y2. And then here they have, looks like y2 minus x1. So it looks like their formula is wrong. Or they lost their organization. So what should it be? It should be subtracting our x's. So if we have 9, what's the other x? It's 4. Sorry, there's no negative on that 9. It's just got a weird neck. And what's our y's? It is 3 minus negative 3. So this is what it should be corrected. All right, and that is number 4. So for 5, 6, 7, 8, 9, 10, we're just going to do some straight up practice of taking these distance. So I'm just going to power through these and probably do at least 2 a page. So first let's start with AB, the classic where we have a 0 0. So really what's that vertical and horizontal distance? So I'm gonna alternate actually and do them formula-wise. So here's the formula one. 4 minus 0 squared, 3 minus 0 squared, 4 squared plus 3 squared, 16 plus 9, 25. I'm going to write don't multiply by 2, do power of 2. And then square root of 25 is 5. And now I'm going to do one by horizontal and vertical feel. So this is going to be, oh, this is AB, right? Number 6 is -1, 7. And C, which is -1, 2. So the horizontal distance from -1 to -1 is just 0. The vertical distance from 7 to 2, how far is it from 7 and 2? It is 5. And whenever you have this 0 component, what it really is just a vertical or horizontal line. So we get another 25, and it turns into a 5 like that. So they're both 5, but kind of in different ways, because this one is just a flat line, this one is diagonal. So there's 5 and 6. And here is 7 and 8. So for 7, we've got E, which is 2f4, and we've got f, which is -1, -1. So I'm going to do this one mathematically. Sorry, this is 2, 4. So I'm going to find distance of EF mathematically by subtracting, after a square root, my x's, 2 minus -1. Then I'm going to subtract my y's, 4 minus -1. Oh, why did I throw in a, I got a free parentheses in here. Oopsies. Alright. So what's going to happen here, 2 minus -1 is 3 squared, 4 minus -1 is 5 squared. So we end up getting 9 plus 25 and a square root of 34. So I'll try to take it apart to 17. Okay, I can't take it apart. So my distance EF is square root of 34. Alright, number 8. We've got G, which is -5, 2. Holy cow, my 2's are bad today. -5, 2. And we've got H, which is 3, 6. So, you know, if it's helpful, you can label up. But this one I'm going to do by feel. So I'm going to do the vertical component. How far is it from 2 to 6? It is 4. And how far is it from 3 to -5? Well, that is 8. So that's how I'm going to find this distance, just by looking at the vertical and horizontal components. So that's going to give me a 16 plus a 64. And GH is going to be square root of 80, which I can take apart, I think. 8, 10, 2, 4, 2, 2, 2, 5. So 1 pair of 2's, 2 pair of 2's, 1 left over 5. So I got 2 2's on the outside and 1 5 on the inside. 4 square root of 5 is my distance. GH. Great. Oh no. Let's just not write that horribly. Good. Alright, so that's 7 and 8. That probably had the most complicated root. And now we're going to finish off with 9 and 10. So for 9, we've got I, which is -3, -1, and J, 2, 11. So we're going to find that distance IJ mathematically. And how are we going to do that? We're going to subtract those x's. So -3 minus 2 squared. And then we're going to find -1 minus 11 squared, because we're subtracting our x's and our y's. So that's a -5 squared plus a -12 squared. Woo, that looks pretty big. So we got 25, where we're doing 2 times 2, plus 144, and that is going to give me a square root of 169, which is a perfect 13. So ij is 13. And that last problem, it's going to say choose 2 points and find the distance between them. I've done that a bunch already, considering I've made up all these problems. So let's just make up a couple problems. Here's, or one last one. We got like -7, 2, and 4, 6. And we're going to subtract and find distance ax. So vertically, it looks like a distance of 4. Horizontally, it looks like a distance of 11. So we got 16 plus 121, and we're going to take the square root of 137, which is, I think, prime, so I'm going to call it at that. This has been my walkthrough for lesson 10. I will see you in the next video.